Welcome everyone. Um, nice to see you out there. I hope you guys are all doing well. So the plan for today is to go through some notation with sets, make sure we have some definitions with sets straight, and then we'll kind of apply our direct proof method to working with proofs with sets. So for example, how do I prove that one set is a subset of another? How do I prove two sets are equal, and things like that. So before we get started, are there any questions out there that I can help with? I do want to just mention that I did post your homeworks, graded homeworks up online. And in case you're not sure, since different teachers might do this differently, just want to make sure you're able to get your comments from the homework assignment. So let me share my browser. And so it probably won't look great here because I actually, as a test student, didn't hand in my first homework assignment. My bad, I missed that one. But when you click on the assignments, now homework 1 has the solutions posted. Excuse me. So if you click on this, you can get a little PDF of the solutions. And I'm grading your homeworks this semester. I don't have a grader. And so as I'm going through your homeworks, I was just jotting down things that seem to happen maybe on like at least a third of the class. I thought that was something that might be worth pointing out to everyone. So there were just some common comments here. If you weren't sure why you lost some credit, this is trying to explain that. As this was your first homework assignment, sometimes it's not quite clear what the teacher is expecting. So I did curve it 1.5 points. So you might see your score on the assignment was this, but it actually got recorded as something higher. That's your welcome to Math 3000 gift. I wouldn't expect that to happen on subsequent assignments. So just want to make sure that one thing is you should be justifying your work. So there was a problem that I can't remember. It was some decide whether you go jogging and you sleep well, if this is true or false. Some people just wrote true, true, false, true, true. You're expected to provide some justification. Maybe that wasn't clear on my end. So you might have lost a point and then gained a point back with the curve. So just watch out for that. The other thing is, as you're reading this, you might see that, man, like he really nitpicked the language on this. That's really not my goal here. The point is to get us all reading things really carefully. And so when you're writing a proof, you really should leave anything up to the imagination of the reader. And so just a couple of things, one of which was question 1E, where you were just trying to decide whether these things were sentence statements or not. And the last one was if you want to solve for X, first do that and then do that. And a lot of people said this isn't correct because that's a command, and a command is neither true nor false. But in fact, that was a conditional statement. So just be careful about that. Although it didn't say if, then, sometimes these things are implied. So for example, this was saying, if you want to solve for X, then do this, that, and the other thing. So that's actually an open sentence because it depends on what came right before that. What is the equation that we're trying to solve? For some equations that works, for others that doesn't work. So just be careful about that. And I think the other one deals with things like 2C and 2D. So in 2C, it says something like, at least 2 students came to office hours. So that would be 2, 3, 4, 5, etc. So the negation of that would be at most 1 student, right? It would be 0 or 1 students came. Question 2D says 2 out of 5 customers paid with cash. And although it might not be stated here, that implies that exactly 2 out of 5 customers paid with cash. Nothing more, nothing less. So if you are technically going to negate that, that should mean, well, not 2 out of 5, which would mean 0, 1, 3, or 4, or 5 out of 5 paid with cash. So just be really careful about how you're reading things. If it's not clear what I'm saying, you're always welcome to ask, and just kind of keep this in mind when you're writing yourself, that if you think that I could see how he might grade this and interpret this a little bit differently, then just try and make your writing as clear as possible. But if you have any questions or comments on how things were graded individually for you, that's something that we probably should talk about individually. I'm happy to do that. But overall, I think the assignments were really good. The way you guys are uploading them, no issues for me. So whatever you're doing worked totally fine for me. And so don't forget, next homework assignment is due tomorrow night. But any general questions about homework and assignments or things like that?
I just had one question about, like, negating a less than or greater than. So would the correct way to do that be, like, if it said greater than, would you say less than or equal to? I mean, if you just said less than, you're still leaving out the equal part.
That's right.
Okay.
Mhm.
Because
Yeah,
it's kind of a subtle thing, but it's kind of like a subtle thing, but I feel like it's important.
It is important. Yeah.
Yeah.
That's right. Yeah, and these sorts of things will also come up for those that are in statistics, how we calculate probabilities in statistics. It makes a difference whether we want to include something or exclude it. Yeah. And so as far as the where you can find your comments when you click on the assignment, let me put it in student view here. Yeah, so you should be able to go into grades. You guys are probably much better at this interface for those that have been using Canvas for a while. I've been doing horrible in this class. Hopefully you're doing better than I am. But if you click on homework 1, you'll see some comments on the side, possibly a rubric. I don't think I'm going to use these rubrics because I'll just indicate on your paper how much I graded each one out of. But then you can see actually the comments. So I just download all of your things because I find grading in Canvas kind of annoying. And I just annotate them and then I re-upload them. So you should see your uploaded assignment with comments written in them attached as one of the comments over here. But if you're having any trouble finding that, just let me know. Anything else? But yeah, I'll just say, like, generally speaking, the homework assignments were looking great so far. So keep up the good work. Okay, so let's take a look at this first worksheet on introduction to sets. Okay, so let's take a look at this worksheet with sets. And this was essentially what you guys were had on the quiz, last couple of quizzes. So this is worksheet 5. Okay, and so got set notation. I think we've kind of had these on the quizzes. So yeah, so we use the empty set to denote the set that contains no elements. We use this n for the natural numbers, which are the integers greater than or equal to 1. We use z for the integers, rational numbers, real numbers, complex numbers. And then we use this inclusion or not in to denote whether or not this thing is in the set or not. So any questions about that, this notation? Okay, if not, then right, we can kind of say this would be true. 7 is an integer. This is false. -3 is not a natural number. This is false because there should be no elements that are in the empty set. Right, this would be false because pi is a irrational number. It can't be written as a fraction of 2 integers. This does not exist in the real numbers, so sorry. That would make that true, right? Because we're saying that is not in the real numbers, which is a true statement. this here would be true. And just to kind of quickly go through these in case you had any questions, since 3.5 is not an integer, regardless of what happens when I plug that into the equation, that's going to be false, right? Because this is saying y should satisfy, this set contains elements that are A, first of all, integers, and second of all, satisfy that equation. So this is not an integer 3.5, so it's definitely not going to be in that set. This is also false, although that is a rational number, it doesn't satisfy this equation. So this checks out, but that doesn't, so that would make it false. Okay, any questions? And I went through that quickly. Okay, so then today we're gonna kind of focus on thinking about really how to prove that one set is a subset of another. So what that means is every element in A should be in set B. For them to be equal to each other, that means one is a subset of the other and the other is a subset of the first one. So in other words, everything in A is in B, everything in B is in A. So I think these proofs we'll get to on Monday. So we'll start some of the next worksheet, but not get through all of that. Okay, and then you did some reading, watching for the quiz to work with these operations on sets. So were there any questions about that, these operations? Okay, so then if we were to take our real numbers, union them with the natural numbers, what would we get? Then we want to do some chatting, some talking. I think this was on the quiz, possibly. Can't remember. So we take all the real numbers and we, join them with the natural numbers. That's going to give us the real numbers because the natural numbers are inside of the real numbers. So we don't add any additional values. If we take the intersection of those two, what would we get? Yep, so that would give us the natural numbers. That's right. And if we take the natural numbers and subtract out the real numbers, what would we get here? That's right. So here, that would leave nothing left. Since every real number is a natural number. So if we subtract all of them out, we have nothing left. So for this one, right, we kind of read our operations first by saying we're going to take the set 1, 2, 3, and we're going to subtract from it the set 1, 2, 4, which would give us just 3 left over after that, right? And then we would union that with 5. And that would give us 3, 5. So we got to be careful how we read these things. And let me just say, it would be different if I had it like this. And we first unioned it and then did the subtraction. So you just want to be careful how you do things. And we'll do it like we read arithmetic things, and we'll go from left to right. And if you want some operations done first, then you should indicate that with parentheses. I don't think that's really going to be an issue this semester. And then if we take the complex numbers and we subtract out the real numbers, anyone know what we would get for this one? Yeah, so we're going to get imaginary numbers, which are not in the real numbers, or irrational numbers. That's right.
So that means what's going to be left over is going to be complex numbers union with, oh, sorry, we don't have a symbol for irrational numbers. Okay, any questions? I'll be right back. I left my coffee in the other room. I wanted to make sure that you guys didn't leave. Okay, so to kind of ratchet up the difficulty a little bit, let's think about now working with maybe some more continuous sets of values. So, right, so this would mean when we use this notation, right, all of the values between 0 and 1, including them. When we use the open parentheses, that means we're excluding them, as what came up when we were starting class today about, yeah, we need to be careful about whether we're including or excluding these things. So what do you guys think about 1? Is that true, that if I take the intersection of all of the numbers from 0 to 1 inclusive with the numbers from 1 to 2 exclusive, what should I get here? Yeah, so we're getting some falses. Great. So this is false, and actually what should this be? So what numbers would be between 0 and 1 inclusive and also between 1 and 2 exclusive? So Nicole, can you complete your symbol there? There you go. Empty set. That's right. Thank you. So this would actually leave nothing, right? Because 1 is included in the first one, but not in the second one. Yeah, don't worry about it. I like answers, whether they're right or wrong. Cool. So in 2 empty set, right? And be careful here, right? That's not is this in the set? This is saying, is the empty set a subset of the real numbers? So in other words, is every element in the empty set an element of the real numbers? Yeah, so that is actually kind of true because there's nothing in the empty set. So yeah, everything in the empty set therefore is in the real numbers because the empty set has nothing. So the empty set is a subset of every single set because it has nothing. So it's going to be included in any set. Okay, 3. Oh, sorry. It's not a little less challenging, right? So that would be true because the element 1 is in the set 1, 2, 3. Okay, if I said that would be false because 1 is a number and not a set, right? It's a different object. So you want to be careful. The set containing the number 1 is different than the number 1. But 1 is an element, of this set. So it's different saying something is inside of a set as opposed to saying something is a subset of it. So we should be comparing 2 sets if we want to consider one a subset of another. Okay. Yes, so yeah, that's exactly right. So this one would be false, right? Because the set containing 1 is not an element of the set 1, 2, 3. The set 1, 2, 3 only has 3 elements, which is the number 1, the number 2, and the number 3. And again, the important thing here is we're considering these things different. This is a number, and that's a set. Okay, what do you guys think about the empty set intersection with the set 1, 2? In question 5. Getting falses, getting some trues. Yeah, so this is going to be false overall. If we flip that to a union symbol, then it would be true. With the intersection symbol, this is saying what are all of the elements in this set and in this set. And since this set has nothing, then their intersection is going to have nothing in it. So the union, or excuse me, the intersection here would be the empty set. Okay, so eventually we're going to start to think about some things that are called like power sets. And these are going to be sets whose elements are other sets. Okay, so sets contain elements. Those elements can be numbers, they can be letters, they can be words, they can be other sets. So here, what we're saying is this is a set that contains 2 elements. One of them is the set empty set. And the other element is the set containing the set empty set. So if these are our 2 elements, would we consider the empty set as an element of this set? That's right. So that would check out. And for this 7th one and the last one here, this is a set that contains 1 element. Which is the empty set. And this is a set that contains 2 elements. And so when I intersect those things, it's going to say, what are the elements that are in both of these sets? Right? And it says, well, this is in the first set. This is in the second set. So therefore, when I take this intersection, am I going to get the set containing the empty set, or am I going to get the empty set? So we got 1 vote for empty set. We've got 1 vote for the set containing the empty set. Anybody else, say with a camera that's not on, you guys hopefully are there and able to chat as well. Would like to hear from some of you as well. So we don't get participation trophies on Zoom here. You don't get anything for just showing up and passively trying to absorb this stuff. You're not going to learn it. The more active you are, the more this is going to sink in. Okay, so I'm getting a lot of votes, I think, for maybe this, which is the empty set alone. So remember up here, these 2 sets, their intersection was equal to the empty set, okay, because they didn't share any elements. So the empty set contains nothing. So if I say the intersection of this and this is equal to the empty set, that means this set and this set would have no elements in common. but they do, right? They both contain the element, the empty set. So when we talk about the intersection, this would be the case if they share no elements. If they do share an element in common, then the intersection is going to be the set containing all of those things. And so since the empty set is in both of these, then we're going to write the intersection is equal to the set containing that thing. So this statement over here is actually true because the empty set is indeed in both of those things. So again, we just want to be careful that we're treating the set containing an element and the element itself as different things. Okay, any questions? Yeah.
Yeah, I had one. Would you refer to that then as the empty set, or how would you describe that?
Yeah,
'Cause
so
it's like a set, but of a set.
Yeah, in words, you would say this is the set containing the empty set.
Okay, set containing empty set. All right,
Where
thank you.
this is just the empty set. Which is a set that contains nothing. So that's where they're slightly different. Yeah, so it's weird. We're used to thinking about sets of numbers. I think that kind of makes sense. But we are also going to think about, at times, sets whose elements are sets themselves. So we just want to start to get prepared for that. Any other questions before we now start taking a look at how we can do some proofs with sets? Okay, so yeah, so next up then would be worksheet 6. So I think we'll get through some of this together today, and then we'll get through the rest of it on Monday. None of this is on the homework assignment. So none of this stuff with sets is on the homework. So, you know, we've been talking about just trying to like organize some study habits for this class, because it's a bit different than some other math classes we'll see, in that I was saying, I think it's useful to keep a running tally of the definitions that we discuss so that you have them to refer to, and any previous results that we've proven together in class or that you've proven on homework, you're welcome to use. In addition to that, I think it's useful to kind of have a separate sheet of like, here's proof techniques in general. And so far, what we're going to talk about today is, we'll have other proof techniques with sets, but today we're going to look at how we can apply this one proof technique that we have, direct proofs. And so far we have like one proof technique. Which is direct proof. Which is okay. We're going to assume P is true and then work to the conclusion. So that's the technique we're going to apply today. And so in addition to that, we'll kind of learn some very particular proofs with sets. So one of them is going to be, how do I show that something is an element of a set? So here's kind of another proof technique. And yeah, and so to kind of prove this, we just need to show that whatever the condition for being in the set is satisfied. And so here's something that is on your homework, actually. You've got one proof that has to deal with saying, like, if this thing is divisible by some number and this thing is divisible by some number, then show that I think their sum is divisible by that number. So that's going to require you to use this definition for a divisor. And this is going to be something that we use quite frequently. And this is something you're familiar with, I'm sure already, but we would say that some number, in this case, an integer, these are both integers, that A divides B if B is equal to A times C for some integer. So for example, we say 2 divides 8, since 8 can be written as 2 times an integer, in this case 4. So that's all this is saying. So if I want to prove that 18 is an element of this set, then what we've got here, the statement P of X. So what I mean by this is it's a statement that depends on the value of X. So then what we need to check is 2 things. Does 2 divide that? And if I want to use this notation, and does 3 divide X? And in order to show that X is an element of this set, and I suppose there's kind of a third condition here, which is that it's an integer. And so as long as all those conditions are satisfied, we're good. So we want to kind of prove this. Right, we got 18 is indeed an integer. Since 18 is equal to 2 times 9, 2 divides 18. Okay, so that would confirm that this is actually in this set. Okay, so we were essentially doing that on the previous worksheet, maybe without being as formal as that. But what you need to basically show is that there's going to be some condition for something to be an element of that set. And you just want to make sure for the given value or the given object that it satisfies all of those conditions. Any questions? Okay, so what I want to kind of focus the rest of the time, was there a question? Yes, sorry. Yes, Max.
I was just curious. Here, 1 second, maybe. I'm gonna use my annotate, but I know how to delete it. I was just wondering, with this line right here, is that the same thing as the colon symbol? Or are we saying divide?
Yeah, I see what you're
there?
saying. It is, and that's a bad use of it
Okay.
here because we have this division symbol. Yes, you're right. Thank you.
I just was curious. I hadn't seen it used like that before, so thank you.
You're right. I shouldn't use it like that. Yeah, thank you.
I also have a question.
Yep.
For definition 1, since you mentioned like some integer C, do we have to incorporate that into our proof?
I mean, yeah, if you want to, I mean, I think what's kind of implied here is that 9 is an integer. So yeah, if you want to be really explicit here, then you can say 18 equals 2 times 9. 9 is an integer, thus 2 divides 18. I left that detail out. I would say it's safe to assume, I think that, someone would realize that 9 is an integer, But yeah, I think if you want to be really explicit, certainly the more you include there, the less you leave to the reader, and the reader appreciates that. So I appreciate that when I'm reading proofs.
Okay. Thank you.
Yeah, I would say it's not necessary, doesn't hurt. Yeah. Okay. So yeah, so let's kind of think about today how we can go through and prove that something is a subset of another. And in order to do that, it involves showing that something is an element of a set. So that's why we just first wanted to go through that process. So we're going to learn other ways to prove this. So here, what we're really doing is, how do I prove A is a subset of B using direct proof? And so this is really an implication saying that A is a subset of B. And the statement that we're trying to prove here is, if X is an element of the first set, then it has to be an element of the second set. And that is, by definition, what it means that A is a subset of B. So we're really not introducing a new proof here. We're introducing maybe a new definition about subsets, but otherwise we're going to prove this the same way, which is we're going to start with P, and then we're going to try and show that we end up with Q. So just what's changing here when we're proving subsets is our statement P is always going to be, let's start with something in element A. We're going to go through some logical, series of logical arguments that hopefully eventually are going to show that that element is in B, which is statement Q. So it's still the same sort of proof of assume P is true and then show that statement Q is true. Max, is there another question or?
No, I just forgot to lower my hand. Sorry. Oh, then I lowered it as you were raising it. Sorry.
Okay.
You got it.
Okay, so let's go through one of these together, and then I think it will be a good opportunity for you guys to practice some in breakout rooms, and then we'll come back together to talk about them. So let's see. I'll leave some of these for you guys to work on. Let's do that. We'll do the last one together, and then you guys can try some of the previous ones. So here's number 5. So we are going to try and show that if A and B are two non-empty sets, then the intersection of A and B is going to be a subset of B. And just to be really clear, what I'm saying here, so the reader doesn't confuse anything, I put parentheses here. I don't think you need them. It's pretty, I think it should be clear what's trying to be stated here, but I suppose the part that might be confusing is you might just kind of see something like this. So this kind of lets it really clear that the two sets we're comparing is this intersection with the set B. So yeah, I guess we can call this element whatever we like. So these proofs are always going to start with, let's take an element, that's not the right set, excuse me. So I'll call it X. Let's take some element X, which is in this set. Okay, so our set A, meaning the set that we're trying to show is a subset of the other. And I left the blank in between because, yeah, we need to say something to connect these two. But just trying to kind of put together like what the general outline would look like for this proof. So kind of any questions about this template? And again, like we can just kind of start with this template, and the only thing you want to make sure is whatever set is here, we're going to assume by starting with something in there. And whatever set is on the other side, we're going to try and show that X is in there. Okay, the letter X, that's nothing special about choosing that as my element. And so then, you know, it works pretty similarly to these even and odd proofs that we were doing, is that you might want to just first start explaining, writing out by definition, what does it mean that X is an element of the intersection? So if X is in the intersection of A and B, then we know that X is in A and X is in B. And I think at that point, we're done, right? That's what we wanted to get to over here. So we want to just kind of keep going through arguments until we get to this point. And once I get to that point, we can stop. Okay, any questions? I don't know why I did that. Okay, wanted to go back to these that we skipped for the time being. So yeah, so now in breakout rooms, let's try and give these a shot. And again, I might suggest that I'm going to change the order a little bit. That I'd like all the rooms to kind of work on the same one. So maybe when we come back together, we've all had a chance to think about it. I don't expect you to get through all of these. Maybe you will. But at least let's start with 3, then go to 4, and then go back to 2. And I think it is maybe helpful for you in your groups, you know, to just think about the template here. Okay, now these get a little bit more complicated, but that's the general idea, right? We start with something on the left set. We want to show that it's an element of the right set. And then as far as how I go from the start to the end, that's going to depend on things. But when you're thinking in your groups, you might want to think about, what does this mean? And then think about, well, if I want to get to this conclusion in the end, what is it that we would need to show?
Does that bar above the B mean not B?
Yeah, this is the same thing as saying B complement.
Complement, yeah, complement. Okay, cool.
Just know that, yeah, both of these sets of notations are used sometimes, yeah. Yeah, so I think, you know, that would be kind of hopefully some place to get you starting when you break up and you're talking about these in your groups. You know, here's my start, here's my end. If we know X is in here, like, let's write out what that means. And if you get stuck along the way, you might want to think ahead towards the end and think about, well, what's the goal here? I would like to show that X is an element of the set A, and in addition, it's an element of the complement of B. And once I show those 2 things, that would be enough to claim that that X is an element of A intersect B complement. Okay, any questions before we try these in breakout rooms? All right, we're back in Brady Bunch land. Okay, so at least the groups that I checked in with, that was great. Really, really nice work. Yeah, and so I think for now, these proofs are maybe a couple sentences long, and that's where we start rather than proving really longer things. So we'll kind of work towards some more involved proofs. But today I just want to make sure like the general outline of how these proofs go are looking good. So let's see. Does someone want to kind of take the mic here and walk us through what your breakout room came up with for question 3?
I can. I don't mind.
Oh, thank you. Awesome. Is that Giselle?
Yeah. Hi.
Yeah, awesome.
Yeah. So we started with I think the first sentence that you had where it was suppose or let X belong to A minus B.
Mm-hmm.
And then suppose X is in A, or X belongs to A, and X, or therefore suppose X is in A and not in B.
Yeah, so let me kind of just hit pause there. That's great. Yeah, and so, you know, here's where we need to be like careful about the words we use. So this is right. So there would be a difference if here I said like suppose instead of then. Just so you know, like suppose means we're assuming this, whereas like then means like this follows from the previous thing. Yeah, so that's right. So we supposed X is in there, and that tells us then that X is in A and X is not in B. Great.
So then is more of the implying rather than we're assuming.
That's right. Yeah. So when you say something like then, this is implying that from this, right, this immediately should follow from that without any kind of intermediate logic in between. Yep. So that's great. So yeah, so here's like definition of what it means to be in there. And so notice at this point, we haven't said that X is in the complement of B. So that is here, but like if we're doing this carefully, we don't want the reader to have to make too many jumps. So we're just literally writing out what does it mean to be in A minus B. Great. All right, Giselle, back to you.
Then we said as X does not belong to B. As X does not belong to B, then X does belong to B with the bar on top.
Yeah. Yeah.
All right. What's the word for that again? I forgot.
Complement.
Compliments. Yeah. X does belong to
differently than like you know, awesome job compliment. But yes, it's the same. We pronounce it the same way. Yeah.
Yeah. So as X does not belong to B, then X does belong to B complement. Therefore, X belongs to A. Or wait. Yeah. Therefore, X belongs to A and B complement.
Yep.
And this shows that since X belongs to A minus B and X belongs to A X belongs to A minus B and A intersect B complement. Therefore, A minus B is a subset to A and B complement. I don't think I worded that very properly, but I was just trying to like reiterate that it belongs to both, and therefore one is the subset of the other.
Yeah, so I think what might be useful here, I mean, sometimes we get to the end of the proof, which is like kind of where we're at here. And then like it doesn't quite join perfectly with how we might intended things. So you're certainly welcome to tweak it a little bit, but that's right. I think if we want to show this, we need to show that X is in here and X is in here. So we've got X in A, we've got X in B. So this shows that X is in exactly A intersect B complement and therefore this is a subset of that. And just so you know, right, when you're handing in your proofs, I just want to see like your final version of it. So if you had some kind of stuff in there that was kind of scratch work, just to be sure, like, because sometimes you say like show all of your work. What does that mean for a proof? That means I want to see just like your final version of it. It's like make some rough drafts, but then when you hand in your final paper, you want it to be kind of the complete one. So just to see what that might look like, this would be a totally good proof right here. Great. Thank you.
Thank you.
Did any groups kind of go about this differently?
I have a quick question.
Yeah, sure.
So like before you say this shows, if you wrap around and you say like this shows, like this shows that since X is the element of A minus B and X is the element of A and B complement, therefore A minus B is a subset of A and B complement. Can you do that, or is it better just to refer to what you previously just worked on? Do you know what I'm saying? Does that make sense?
So you're saying after we said this, to say what?
Do you mind if I screen share? Maybe it's a little
not
easier.
at all. Let me stop mine.
So like, can you say like starting here, this shows that since X is the element of A minus B, like you refer back to the beginning, and X is the element of A and B complement, A minus B is a subset of A and B.
Yeah, I would just change the writing very subtly here. I think I might be able to annotate this. Yeah.
You can, when you go to the top, there should be a view options, and then it gives you the annotate option.
So really what you're saying, not since, you're really saying, since this shows that if X is in here, because we're trying to prove a conditional statement, technically, that's right. So, and that's a then there, I'm trying to draw with my trackpad. But it's really saying, this shows that if X is in A minus B, then X is in that intersection, therefore it's a subset. So I would just change that very subtly from like an and statement to a conditional statement.
Okay, sounds good.
Yeah. Any other questions? Okay, so let me go through question 4. Since we've got just a couple minutes, I'll kind of walk through from what I picked up on the other groups that I listened to. So I'll just kind of narrate. So on this one, it's the flip side, right? Very similar to 3, except now we're going to start with something in A intersect B. So it should almost seem like we can take that previous proof and almost like flip it on its head, right? And just kind of really, now we're starting from here and we're trying to work our way up there. So we've got X is in here. So that would tell us then that X is in A and X is in B complement. So that's like what we got here, right? So we're just kind of working in the other direction. And so if I want to show that X is in A minus B, if you're kind of thinking about it this way, we could kind of think, what would the second to last line need to be here? And we would want to show that X is in A and X is not in B. That by definition is what it means to be in A minus B. And I think we can pretty much, that's it, right? We don't need to say much. If X is in B complement, that is by definition saying that X is not in B. Any questions about that one. So just to let you know, then we're heading for next time. So we'll go back to that first one that we hopped over. Sorry, I just saw. So there was a question about can you skip saying the definition or should you include it? So in other words, does that mean do we need this? Is that the idea?
I think she's asking if we need to say that it is the definition after stating it. Am I right?
Like the sorry, I'll just unmute myself. Like, do you need to say that by definition, if X is in B complement, that means it's not in B?
I see. No. Yeah. So in other words, something like since X is in B complement, then X is not in B. Yeah, I don't think that hurts to say something like, I mean, certainly saying by definition, since this isn't there, we can say that. I don't think that does any harm. Sometimes you might want to think about, not making this concise, but I think adding that one sentence is good. It doesn't make it all that much longer, and it saves the reader from having to think. That's always a good thing. Yeah. Okay. Yeah. So just to kind of see where we're going, for next time, we're going to work with how do we prove that two sets are equal. And to do that, we're going to need to prove two things. This is a subset of B, and then B is a subset of A. So we need to show that they're both subsets of each other. And that's what we did in these questions 3 and 4. So by 3 and 4, we just proved, therefore, A minus B is actually equal to the set A intersect B complement. So next time we'll be working more with these sorts of sets. We'll be proving sets are equal to each other, and you can kind of think about that as a biconditional proof. So we're going to need to prove both directions of that. Great. Okay. So thanks everyone. Really nice job on the proofs. That's great. And so have a nice weekend. If you do have any questions, I have office hours tomorrow from still getting used to my schedule here. Tomorrow's office hours are from 10:30 to 11:30. And I'll be around. So if you want to meet at another time that's not convenient, just let me know. Otherwise, I'll have a nice weekend, and I'll see everybody on Monday.